Okay, college algebra. You guys should have your notes in front of you, and let's check out these notes. Here's what I've got. We're going to be starting graphing polynomials, and we're going to be doing dividing polynomials. So what I want you to do is flip to the second to the last page in your notes. You should get to this type of shape right here, and we're going to fill out this little bit of notes and organizer for how to graph these polynomials. First degree equation, y is equal to x, has this type of shape. You guys know that. Y is equal to x squared has this type of shape. Y is equal to x cubed has this type of shape. Fourth degree, y is equal to x to the fourth has this type of shape. And y equals x to the fifth, you kind of see a pattern developing, has that type of shape. And so part of what I want you to understand, if you look at kind of the maximums or minimums or the bumps within the graph, this first one has 0 bumps. This second one has 1 bump. This next one, this third degree, has 2 of those bumps. This fourth degree has 3, and this fifth degree has 4. And so this part says local extrema of a polynomial. Given a polynomial of degree n, there are at most n minus 1 extrema. So we call the extrema those bumps. They're either the maximums or minimums within that given set. And so we can kind of predict the shape of the graph knowing that there's, if there's a 6th degree equation, there's at most 5 of those bumps. Okay, so that's something that's important to see there. Another thing to notice is that how these finish. Look at how they all finish. This one finishes going up. This one finishes up. This one finishes up. This one finishes up. This one finishes up. So if n is odd or if n is even, as long as they're positive, they finish going up. So as x goes to infinity, y also goes to infinity. So as you head to the right in all these situations, I head to the right for x, the y value goes up as well. As I head to the right for x, the y value goes up, so on and so forth. Now, look at the even functions. Look at the even functions, okay? So look at the fourth degree. It starts up and it ends up. The second degree, it starts up and it ends up. Well, if they're even, they start and end in the same direction. So if n is even and it's positive, then as x goes to negative infinity, y goes to positive infinity. Look at the odd ones. It starts down. So as x goes to negative infinity, the y value drops. Another one, the third degree, is x goes towards negative infinity, the y value drops. And the fifth degree is x goes to negative infinity, the y value drops. So if n is odd, as x goes towards negative infinity, then y goes towards negative infinity as well. Now I'm going to draw the opposites, and you can just sketch right over it. I just want to do it so you can see it. But suppose we were drawing the negative graphs. Well, the negative graphs look like this. The x graph will go down. Parabola will go down. Third degree. Fourth degree looks like something like that. Fifth degree, something like that. And if you look at it, they all finish going down. They all finish going down. So as x goes towards positive infinity, okay, if n is odd and negative, then y will also go towards negative infinity. If n is even and it's negative, y will go towards negative infinity. If they're positive, they finish positive. If they're negative, they finish negative. Doesn't matter whether it's an odd function or an even function. But again, as you look here, look at the even functions. Look at the second degree. It finishes down and it starts down. The fourth degree, it finishes down and it starts down. So if they're even, they start and finish in the same direction. So as x goes towards negative infinity, y goes towards negative infinity as well. But the odds, they're opposite. If the odds finish down, they start up. They finish down, they start up. If they finish down, they start up. So as y goes towards negative infinity, or as x goes towards negative infinity, y goes towards positive infinity. Now, you don't have to memorize this chart. The important thing to remember is this. If they're even, they start and finish in the same direction. If they're odd, they start and finish in opposite directions. If they're positive, they finish up. If they're negative, they finish down. Simple as that, okay? So we'll do some practice here in a little bit. You guys will get it. Just there's a little bit of that thought. The second thing we want to talk about, other than those general shapes, is these type of roots. There's different types of roots you can have. You can have a single root, and a single root just passes right through the x-axis. That's a single root. If there's a double root does this. It comes down and it touches tangent and bounces back up. And a triple root, it will come through and it'll flatten out right at that spot and then pass through. So there's single roots, double roots, triple roots, there's quadruple roots, but I just show you the first three. And if you look at the graph right below it, this guy right here, you can see what kind of shape you get. For example, this root right here, this is a triple root. This root right here is a double root. This root right here is a single root. This root right here is a triple root. So that graph kind of shows you the shape that's on the map. So this is a polynomial we could graph. I know you guys might think it's crazy that you would maybe graph that, but I'm going to show you something that's pretty cool right now. You have a triple root, a double root, a single root, and a triple root. Well, so what that means is if it passes through an x value of -2, that means that x plus 2 is part of the solution. And since it's a triple root, it's cubed. And then the next one passes through 1. So x minus 1, since it's a double root, it's squared. And then this one passes through 4. So x minus 4. And the next one passes through 7 and is a triple root. So x minus 7 quantity cubed. That's actually a really good example of what the graph should look like. In fact, I'll try plugging that right into the calculator. If you want to, you can plug it in with me. But x plus 2 raised to the third power, x minus 1 raised to the second power. Well, I'll just go squared. Sorry about that. Then x minus 4. Then x minus 7 raised to the third power. So I've got that plugged in. If I go to my window, I get this same type of dimension. It looks like we've got -4 is our x value for our min, and then 8 is our other value. It looks like a tick mark every 2. And we go from -50,000, all the way up to 40,000. We got tick marks every 10,000. And hopefully if I graph it, I get that. If I didn't, I'd type something in wrong. Let's see what we get. There we go. Just by looking at the graph, we were able to come up with the equation. And that's the power of polynomials, being able to determine it. So hopefully you guys find that interesting. It's good stuff. And now we get the chance to graph them on our own. So flip to your notes to the very, very front. And this is kind of based off of what you're assignment is going to be to sketch a graph, really a rough graph of the polynomials, and these are already in factored form. So f of x equals x minus 2 times x plus 3. So what I like to first decide is the degree of the polynomial. The degree of the polynomial is 2. And it's a positive x times a positive x. So that means it's a positive polynomial. And if it's positive, that means it will end going up. And the question to you is, if it ends going up and it's an even degree, then how will it start? And your response should be, it starts and ends in the same direction. So it's going to start up and end up due to that degree. So all I do is I just draw a little graph. It crosses through 2 and negative 3. So I plot 1, 2, 3. I plot 2. And it starts up and it finishes up. It's just a parabola. That's it. That's all I have to do. The next one, it looks like I have a degree of 3. I have solutions of 5, 1, and negative 4. If I were to multiply this out, I have it looks like I got that negative in front, so I get a negative x cubed, so it's a negative polynomial. So as soon as it's negative, that tells me it's going to finish down. It's negative, so it will finish down. Well, if it's odd, then it starts and ends opposite direction. So it will start up and it will finish down. And now I can start to kind of generate this type of graph. I'm going to plot 5, plot 1, and start up and finish down. And there you go. That's a rough sketch of that graph for you. The next one, we also have degree of 3. And it looks like when I multiply this out, I've got a negative 5 there, I've got a positive 1. When I multiply this out, I have an x times an x times x. I'm going to have a positive x cubed. And so because it's positive, it'll finish up. And because it's odd degree, it will start and finish in opposite direction. So it starts down and finishes up. So I have roots at 0, 1, and negative 5. 1, 2, 3, 4, 5. 1 and 0, starts down and finishes up. There's a good graph for you. Do a few more, okay? Just kind of get the hang of it here. Where we at the video, we're about 12 minutes, okay? Next one. What's the degree? I should have said 3. Is it positive or negative? It's negative. I would get an x squared, and then negative x will make negative x cubed. Since it's negative, it finishes, should be down. And since it's odd degree, it starts and finishes in opposite direction. So it'll start in the up direction, it'll finish in the down direction. What's different about this one is I have a double root of negative 4. So since it's x plus 4 quantity squared, it's a double root of negative 4. So what that means is that it's going to touch tangent at that negative 4. I'm going to put D for double root. And then it passes through 0 as well. I have a 0 solution as well. So as I start up, I have to come down, and I just touch, and I bounce off, and I pass there. Some of you, this whole graphing thing will come more intuitively than to others, and it's okay. Don't get super frustrated by it. Just do your best as we work through it. This one, number 5, a little bit more difficult. We got the degree here. The degree is going to be 5. I'm sorry, not 5, but 4. Very good. Degree of 4. We got to decide if it's positive or negative. So I got positive x. Now I've got a negative x here, and I got a positive x there. So when you multiply these out, you're going to get a negative x to the 4th. So it's going to be a negative polynomial. And since it's negative, it finishes down. But since it's even, it starts and finishes in the same direction. So there we have it. Starts down, finishes down. It looks like it's going to cross through 5, negative 3, 3, and negative 5. So I got to plot 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Plot 5 and 3, negative 5. Starts down, finishes down. They're all single roots. Just looks like that. Now we'll get a little bit complicated. What is the degree of number 6? Should be 5th degree. Positive or negative? Should be positive. If it's positive, it ends going up. It starts opposite. So it starts down because it's an odd degree. Okay, looks like I have a triple root of 0, 0, 0. Looks like I have a double root of 4 and 4. So that's what I want to try to show. I want to try to show that behavior. So it's going to pass through 0 with a triple root and pass through 4 with a double root. Well, a triple root kind of flattens out like a cubic, and then the double root, it just touches tangent. So that's a good picture of that graph. That's a good picture of that graph. Do a couple more here, then we'll let you go to work on your assignment. I'm looking ahead here to see, we don't need to try all of these. Looks like I went a little bit overkill on the notes for what we needed to practice. But we'll do a few more. Number 7. That's a real good problem. What's the degree? The degree should be 4. And is it positive or negative? Well, you have a positive x, and then a negative x. This could be a negative. And because it's negative, it will finish down. Since it's even, it starts and finishes the same direction. So we have solutions of 5, -1, and -1. So I got a double root, -1, and a solution of 2. So I'm going to make my graph. 1, 2, 3, 4, 5. Back 1 to -1. And over to 2. So I have again, it starts down, it finishes down. It's got a double root at -1, so I bounce off. Single roots at both 2 and 5, so it's going to pass through 2 and pass through 5. There we've got it. That's my graph. Number 8, what is the degree? Should be 5. Positive or negative? Should be negative. So it finishes down, starts opposite because it's odd degree. I have solutions of 0, 0, and 0. Solution of -2 and +4. Triple root of 0. Let's see, 1, 2, 3, 4. 1, 2. Okay, so it's going to start up. It's going to pass through -2. It's got a triple root action at 0. It drops right down after that. All the rest are pretty similar. I am going to try number 10 with you real quick. I'm going to let you work. Number 10, the degree is 4. It is positive, so it means it ends up. Since it's even, it starts and ends in the same direction. I have solutions of 5 and 5. -3 and -3. So I'm going to mark out 5, -3, -3. And those are both double roots. So it's going to start up here. It comes down, it bounces off, and then it bounces off again. That's what that graph looks like. So, good opportunity for you guys to get some practice with this. There are more practice problems in your notes. We really don't need to go through them all. A lot of them are really, kind of examples that we've already seen. But you do have an assignment that you can get working on. Tomorrow we'll be working on dividing polynomials. So good luck. Hope you do great. I look forward to seeing you guys soon.